In this video, we will look at triangles. Triangles can be classified in two main ways. First, by their angles, and then by their sides. So if we look at the angles, if all of them are less than 90 degrees, we call it an acute triangle. If one of the angles is 90 degrees, then we call it a right triangle. And if one of the angles of a triangle is more than 90 degrees, we call that triangle an obtuse triangle. Secondly, we can classify angles by their sides. So if a triangle has all three sides equal, then it is called an equilateral triangle. If two sides of the triangle are equal, then we call that triangle isosceles. If none of the sides is equal, or it has three different sides, then it is called a scalene triangle. There are other parts of a triangle that help us to describe and also solve problems related to it. For example, we have the median, which is the line drawn from a vertex of a triangle to the midpoint of the opposite side. So the line formed is called a median. Another term is the centroid. Now, this is the center of an object's mass, or the point at which the object balances when placed on a pointed device. It is also known as the center of gravity of the object. Now, how do we find the centroid of a triangle? We would have to intersect all three medians drawn from all three vertices of a triangle. The point of intersection will be the centroid. In our example triangle here, we just drew the midpoints and they all intersected at this section called the centroid. Now, there are other angle properties of a triangle which help us to solve problems related to triangles. We'll look at what we call an exterior angle and interior angle of a triangle. Let us note that all interior angles of a triangle sum up to 180 degrees. But how do we know the angle formed when we extend a line on one of the sides of a triangle? First, we know that all three interior angles sum up to 180 degrees. Also, the two adjacent angles on a straight line sum up to 180 degrees. So angle ACB plus angle ACD sum up to 180 degrees. If we were to draw a parallel line to line BD, which touches the vertex A, we realize that the line AC forms a transversal when extended. So that means that angle ACB can be drawn here. So these angles are equivalent. Now, when that happens, these two angles are also co-interior because they are on the same side of the transversal. So we can say that angle ACB, angle ACD add up to 180 degrees. So if both equations add up to 180 degrees, then we can equate the two equations. When we do so, angle ACB cancels out, and then we have angle A plus angle B is equal to angle ACD. Now, this establishes a fact about triangles, that the sum of two interior opposite angles add up to an exterior angle. So in summary, the main angle properties of a triangle are these. You have a triangle like this with interior angles A, B, C. They all sum up to 180 degrees. And that's the sum of two interior angles, opposite angles, add up to the exterior angle. Angle B plus A sum up to F. C plus B will sum up to D. And then D plus A will sum up to E. Now let's see some questions involving angles in general and then that's of triangles. In this example, we have line 1 and 2 which are parallel. We are supposed to find the value of x. Now, as we just learned, these angles are both co-exterior angles because they lie outside the two parallel lines and they both add up to 180 degrees. We can simply add 143 plus x and equate it to 180 degrees. So if we solve for x, we'll get 180 degrees minus 143, which is 37 degrees. Let's see another example. In this example, we have two parallel lines. We have to find the angle B. How do we go about it? Let's remember that this diagram depicts two traversals cutting through two parallel lines. So this is the first transversal and this is the second one. Now, what that means that these angles are corresponding, so they are congruent. So this angle will also be 40 degrees and these angles will also be 60 degrees because this will be corresponding to that. Now, if we were to find the angle B, we'll have to add all three and equate them to 180 degrees. So we'll have angle B plus 60 plus 40 degrees equals 180 degrees. So angle B plus 100 equal to 180 degrees. So therefore, angle B is equal to 180 minus 100 degrees, which is 80. In this question, we are to show that angles A and B sum up to angle ADD. This time, there's a parallel line DE to the line BA. How do we solve this? When we look carefully at line BD, it is a transversal because it is crossing the two parallel lines AB, then DE. So that means that these two angles, which we'll call alpha, are equal because they are corresponding. Secondly, these angles we'll call beta are alternate interior angles and are also equal. So now what forms the angle ACD? It is angle alpha plus angle beta is equal to angle ACD. And this has proven that the sum of the interior opposite angles of a triangle equal the exterior angle.